Hi. All right, today's video is going to be on the different aspects of the different functions that we have. If you remember, when we started transformations, I said that and aspects. Those are the two biggest ideas from Unit 0 that we got to get everybody caught up on, because we're going to be talking about transformations and aspects of functions in every single unit that we talk about this semester. So the different parts of your graph, regardless of what kind of function it is, we've looked at x squareds, which are parabolas, we've looked at x cubes. No matter what the function is, it's going to have these peaks and these valleys, or a peak or a valley. And one of them is called a local maximum. So the local maximum, which we are pointing to right here, is a point which is higher than all the other points right around it. So likewise, a local minimum is a point that's going to be lower than all the other points by it. Now, it doesn't say it's an absolute max or an absolute min, because that means it would be the absolute highest or the absolute lowest. And if we look right here, although this is the high point of that hill, this arrow is going up. That's going to go higher and higher. It's going to go higher than that point. That's why we call it a local max. It's just higher than the other points that are right by it. Some graphs only have a local max. Some only have a local min. Some have both, or some have none. So it's always going to be one or the other. It could be both. So if I'm looking at the first one, do the following graphs have a local min, local max, or both? What I want you to do right now is to push pause and just try it. Shouldn't be that bad. Just push pause, put a point there, and right below local min, local max, both. When you are done, go ahead and push play. All right, let's see how you did. The first one, we've got that hill here at the top. That is going to be the highest point, making it a local max. Number 2, we got that low point, making it a local min. And we go to 3, we've got all these peaks and all these valleys. So we're going up and down, up and down. So we actually have both maximums and we have a minimum. All right, let's move on. Something a little bit more challenging for you guys. Talking about different intervals. We look at a graph, we could have different intervals on that graph. An interval is a specific part of the graph function given two endpoints. So between x and y, well, let's use a's and b's because x's and y's can get confusing on a graph. So between a and b, between c and d, between these two specific endpoints, what's happening on the graph? Remember that x's go from left to right. So when we talk about intervals, we're going to be talking about their movement from left to right. So we have our first interval here, right here. And when I look at this interval, going left to right, there's my line. So if you ask yourself, what is happening in interval A? From left to right. If I go from left to right, is my line going up or is it going down? This can be very deceiving because the arrow here is pointing down. And that's because it's going to forever go down, which is good. But if I go from left to right, my movement from left to right is actually going up that hill. So this is going to be an increasing interval. And if we look over here, the interval of A is negative infinity to 0. Because see how it's going to stop here? In respect to x, we are at 0. It's a negative infinity because this arrow right here, it says that we're forever going down, but we're also forever going to the left. So this is left to 0. If I look at my graph from left to 0, it is going to be increasing because my line is going up. Think about a positive slope versus a negative slope. I always like to write it in this notation because it reminds me that I'm looking at my x value. So it reminds me, look at your graph left and right, not up and down. But you could also write this like that. I just prefer the first way. So my second interval we see here saying part B, interval B. So from here to here. And again, when we read our graph, we start at the left and we move towards the right. So from the left to the right, my line here is going downhill. It has a negative slope, so it's going to be decreasing. So on my graph, from 0 to 5, it is going to be decreasing. I could also write it like this, which again, I don't like this notation because it gets confusing. Am I talking about a point on the graph at 0, 5? No, I'm talking about an interval from 0 to 5. And then our last one, our last interval, we have C. And again, if we go from left to right, my line is going up, so this is going to be an increasing interval. From 5, and this arrow is forever going up and right. This is up and right. This is down and left. So this right here is saying from 5 to the right forever. Not because it's going up, but because it's from 5 to the right, my line is going up, it's increasing. My other way to write this is like that. Again, I like the first way because it reminds me I'm looking at x's. It's reminding me to follow my graph left to right. That's the movement I'm looking at. I don't care if it's my arrow's going up or my arrow's going down. I'm reading my graph left to right. Some people like the second way because it's shorter, but I think it can be more confusing. All right, back page. It is now your turn again. I want you to look at your graph that you are given, and for each of these 4 intervals, I want you to press pause and tell me whether it's an increasing interval or a decreasing interval. Don't forget to press pause, press play when you are ready to go. All right, let's see how you did. The first one, I have my blue interval here highlighted. Remember, this means from the left to -2. So from the far left to -2. This first little section here, my line is going down from left to right, so it's decreasing. Now we're from a -2 to 1. If I'm looking at just that segment of my graph, if I move left to right, my line is going uphill, so it's increasing. And then from 1 to 7, again, the most important thing is that you are reading that graph left to right. I have a negative slope, it's going downhill, decreasing. And 7 to forever to the right, I am going to be increasing because I have a positive slope. Now that's breaking up my function to all these little pieces. The next section here is just talking about the end behavior. All right, the end behavior. Key here is the end. I'm just looking at the ends of my graph. There you go. The very far left and the very far to the right. Now my first one here, it says as x goes to a positive infinity. Remember which direction x's go? X's go left and right. So if I'm going to a positive infinity, it's saying look to your right. This piece right here says look the farthest right you can. When you look at the farthest right part of your graph, what's happening? That right there, my arrow is going up, which means my f of x, which is just a fancy way of saying y. My y is going up, which means it's going to a positive infinity. I'm using positive and negative infinity for x's and y's. It's just a matter of looking at your graph and knowing which one am I asking for. This says as I look to the right, what's happening to my y. As I go to the right, I'm going up, so it's positive, positive. If I look at the next part, it is saying as x goes to a negative infinity. X's are left and right. Negative means as you look left. What's happening when I look left? When I look to the farthest left right here, my arrow is going down, which is why my y is going to be going towards a negative infinity. All right, so the end behavior, just which way are your arrows pointing on the very ends? To the very far left, to the very far right. The next section here is a review of our function notation that we have done for our first quiz. F of negative 5. Remember, what's inside the parentheses, that's your x. What comes out of it is the y. Oops. F of negative 5. When I look at my graph, when I find my x value of negative 5, right there. What's my y value? It's on the axis, so that's 0. F of negative 2. Oh, here's f of negative 2. That also has a y value of 0. F of 0. I think this one got a little off. F of 0. That's down there at a negative 5. F of 4. That means my x value is 4. That's at 4, 0. Oops, forgot my point. This is at 0, negative 5. These are really important parts of our graph. Notice that each of them have a 0 in it. When your y values are zeros, those are actually representing your x-intercepts. So I have an x-intercept at negative 5, 0, negative 2, 0, and 4, 0. Whenever we're listing intercepts, we always list the coordinates of those intercepts. When the x-coordinate is 0, that means it's going to be my y-intercept. Why can there be multiple x-intercepts but not y-intercepts? So if you look here, I have 1, 2, 3 x-intercepts, but I can only have one y-intercept. If I had more than one y-intercept, so let's say we had an intercept up here, then it would fail the vertical line test, and it wouldn't be a function. So you can have more than one x-intercept, but not more than one y-intercept. All right, our last idea for our aspects is domain and range. We talked about this slightly already this unit. Domain is all the values that go into a function. This is the set of all the x values. Range is all the values that come out of a function, and this is the set of all the y values. So let's look back and identify the domain and range of our previous functions. We work backwards. So let's think about our x's. And it's easier sometimes to think about what can it not be. So if I follow my graph left and right, there's no restrictions on x's. My x's get forever small and my x's get forever big. So my domain is all real numbers. Now, I don't like writing all that out. The symbol for all real numbers is that. Now, the domain is going up and down. Well, this arrow is going down. This arrow is going up. There's nothing stopping it in between. So my range just happens to be all real numbers as well. Now, the all real numbers, if you're trying to write that symbol, just write two lines, two parallel lines, and put a big capital R over it. Let's see if we find something more exciting. Okay, this one right here. Our domain, again, is our x's. As we go left and we go right, this is forever going up, but it's also forever going left. This is forever going up and going to the right. So I'm forever going to the left, forever going to the right. No restrictions, all real numbers. But as I start looking at my range, if I go up and down, it's not forever going down. This is going up and this is going up. This right here is the absolute lowest my graph is going to get. Let's just pretend like this point is 7, negative 5. I'm just making that up. That means my range, everything is above that point. Range has to do with y values. So my range is all values where y is greater than or equal to negative 5. So you've got to think about where is it falling on that graph. Think about your x's, that's your domain. their range is going to be your y. All right, and that's going to be it for today's video.